Hello students, in this video we are going to discuss the dimensional analysis and its applications. In these applications also the first application we will discuss and the principle of homogeneity. The dimensional analysis is a tool to find or check the relations among physical quantities by using their dimensions. When magnitudes of two or more physical quantities are multiplied, their units should be treated in the same manner as ordinary algebraic symbols. We can cancel identical units in the numerator and denominator. Similarly, physical quantities represented by symbols on both sides of the mathematical equations must have the same dimensions. And the uses of this dimensional analysis. Dimensional analysis can be used to check the dimensional consistency of equation. That means the given equation is correct or wrong based on the principle of homogeneity, and to convert units in one system into another system, to derive the relations between the quantities based on certain reasonable assumptions. Here in this video we will discuss the first application, checking the dimensional consistency of equations. The principle of homogeneity of dimensions. What it says: the magnitudes of physical quantities may be added together or subtracted from one another only if they have the same dimensions. When that can be possible, either addition or subtraction, if the two quantities belongs to the same nature and they have the same dimensions. For example, initial velocity can be added to or subtracted from final velocity because they have the same dimensions. But force and the momentum cannot be added because their dimensions, the dimensional formula are different. And for force, mlt power minus 2, and for momentum, mlt power minus 1 respectively. For example, to check the dimensional consistency of v square is equal to u square plus 2as. The dimensions of the quantities involved in the equation are u, the initial velocity dimensional formula, m power 0 lt power minus 1, and for final velocity also same. For acceleration, m power 0 lt power minus 2, and displacement is equal to m power 0 lt power 0. Substituting these dimensions in the given equation, m power 0 lt power minus 1 whole square is equal to m power 0 lt power minus 1 whole power 2 plus m power 0 lt power minus 2 m power 0 lt power 0. Here we ignored the constant 2 in the term 2as. So finally, the left hand side m power 0 L square t power minus 2 is there. Right hand side also m power 0 L square t power minus 2 plus m power 0 L square t power minus 2. That means the left hand side dimensional formula, right hand side dimensional formula, both are same, which represents the square of the velocity. So each term of the above equation is having the same dimensions. Therefore, the given equation is dimensionally correct or dimensionally consistent. If an equation fails the consistency test, it is proved wrong. But if it is passing, it is not proved right. Thus, a dimensionally correct equation need not be actually an exact equation, but a dimensionally wrong or inconsistent equation must be wrong. For example, v square is equal to u square minus 2as or v square is equal to u square plus half as are dimensionally consistent but are incorrect equations in mechanics. Albert Einstein tried his famous mass energy equation as E is equal to m by c square, E is equal to m square by c, E is equal to m square c, etc. But finally, he settled with E is equal to mc square using dimensions and then proved it with the help of calculus. One more example. To check the dimensional consistency of half mv square is equal to mgh. The dimensions of the quantities involved in the equation are mass is equal to m L power 0 p power 0, velocity m power 0 L t power minus 1, g is nothing but acceleration due to gravity. Its dimensional formula is equal to the dimensional formula of acceleration only, m power 0 L t power minus 2, height nothing but length m power 0 L t power 0. By substituting the dimensions in the given equation, we will get m L power 0 t power 0 into m power 0 L t power minus 1 whole square is equal to m L power 0 t power 0 multiplied by m power 0 L t power minus 2 multiplied by m power 0 L t power 0. Here the constant half is ignored here from the term of mv square. After simplification, we will get m L square t power minus 2 is equal to m L square t power minus 2. Each term of the above equation is having same dimensions. Therefore, the given equation is dimensionally correct or dimensionally consistent. So, this is the first application of dimensional analysis. In the coming videos, the second and third application will be discussed. Thank you.